Okay, great. Perfect. Thank you. Thank you, Padma, very much for the opportunity. Hello, everyone. I'm Smita. I'm really excited to be speaking to you today. And I'm going to talk about the knowledge graph, how it can power active metadata. Every organization in this world today is data heavy. Plenty of data is available for decision making. However, data still exists in silos. Complex landscape and data growth make data disparate, disconnected, and dark. So it becomes really difficult to realize the true value of data. It can lead to delayed decision making. For example, a typical e commerce platform has multiple channels where a user can place their order via an app or a third party application, website, over the phone. As a business, how do we derive the customer behavior on these disparate applications and leverage it to produce personalized recommendation? Another issue we face is low understanding and fragmented data, which leads to untapped data potential. For example, a mid sized finance company has data in their legacy system, like mainframe, on prem, in their data vault, in their data warehouse, and on the cloud. Given this multiple touch points that the data traveled, how do we trust the data and understand the data? For example, how does a governance team implement a a mandatory GDPR compliance when it doesn't have a full view of how the customer data is stored in each of their line of business? We also face difficulty in end to end impact analysis or what if analysis. A geopolitical issue may impact the raw material supply unless forecasting and production KPIs are overlaid with that information. It would be very difficult to project the production rate and maintain minimum product inventory at store, which impacts sales. Understanding data and context, that is, having a human like intelligence and pulsating data, becomes key to gaining a competitive advantage. The journey begins by knowing your data and making it actionable. So, why do we need active data and how knowledge graph helps? Metadata, like data, exists again in silos. It is factual and it's passive. In order to make it actionable or active, we need to connect this data which is available in silos and enrich it with business knowledge. There are different kinds of metadata that can be tapped into. Technical metadata defines the data. What is the model, the schema, data types, etc. Operational metadata tells us about where the data is hosted, which ETL loads the data, what is the provenance of the data. Business metadata supplement the description. It provides information about the data. It provides the business and the domain knowledge to the data, like data classification, tags, mapping, etc. And lastly, the social metadata, which is not very frequently used, but it does talk about how user consumes our data, interacts with it, which data is being commonly used across platforms, who uses that data and for what purpose. Only by adding context to the data, we can differentiate between noise and signal for any given use case. A data can be given a data set, it can be relevant to one business group. Some of the fields may be relevant to one business group, while for others those fields might not be relevant and they might end up using some other fields. So understanding the signal and the noise, differentiating the signal and the noise for a very particular, in the context of a use case, becomes very important. When all these metadata from different sources come together, we can see that they start telling a story about data, its origin, its journey, who influenced it, and how it evolved. With that 360 degree view of data, we can do a lot of things. We can contextualize data, we can democratize data, have an end-to-end impact analysis, what if analysis. We can, rationalize infrastructure assets, build governance, implement data fabric, data mesh, etc. So, the opportunities are limitless. So, how do we conceptually build this platform? We build this platform in 4 steps: gather information, connect and enrich, sense, analyze, learn, and respond, sentient interaction. Step 1: gathering information. Bring different type of metadata together using catalog connector, crawlers, compute and transformation information, data quality information, data ops information. All these things can be brought together and ingested via metadata supply chain. Connect, the step 2 would be to connect and enrich. Connect this metadata, which has been gathered from multiple different sources, and supplement it with the domain knowledge, ontology, industry corpus, reference corpus, to make this metadata intelligent, to provide the knowledge and context to this metadata information that has been gathered. For example, let's say we gathered information about business processes and KPIs, which then overlaid with technical metadata, build an understanding of how a data set impacts a KPI. In step 3, we take it a step further and make this metadata knowledge graph work for us. We sense, analyze, learn, and respond, where we leverage graph data science and other algorithms to find patterns and derive insights from this graph. The final step, the step 4, is the sentient interaction. The insights that was generated by the step 3 can then be used as information to drive regulatory compliance, build a marketplace, define and implement governance, or generate events and alerts. Different personas can use this information and use it in a way which is beneficial for them. For example, a social metadata like BI tool usage pattern, which linked with operational metadata, can be leveraged to recommend peak usage hour for the underlying warehouse and allocate compute resources dynamically. Or the same can be leveraged to purge stale assets and identify the popular data assets and optimize their storage and delivery. Opportunities, as I said, are limitless once we understand different aspects of data. So, how do we picture a metadata knowledge graph? This is just an illustrative view of how a metadata knowledge graph would look like, and I've tried to bring in all the 4 different flavors of metadata onto a single platform. But in a production scenario, it would be much more complex to look at, and we might be using projected graph in order to do any kind of processing on such a huge metadata knowledge graph. So if I can draw your attention to the blue bubbles, they represent the technical metadata. For example, what is the data type? What are the data fields? Are they sensitive, etc.? The operational metadata is represented by the green bubbles and tell us about where the data was hosted, how it was updated, the licensing detail of the data store, etc. So the purple bubbles are the semantics. They provide the business context to the data. The amber bubbles bring the social metadata and outline how the users interact with data. Given this intuitive picture, it would be very easy to answer questions like, if we make a data model change, how many downstream systems are impacted? Or if a business KPI is impacted, if what happens to a business KPI if a data quality of a data set is very low? Or if a data has not reached on time, right? So these kind of complicated questions which require us to go from one line of business to another line of business, from one department, from one system to another system, in order to answer that question, answer those questions, it becomes very easy when you have just the metadata information in a graphical format and you can see it, visualize it, and derive information. Let me supplement this with an example. Afni is a business data owner and she is responsible for data governance and regulatory compliance. She has been tasked to ensure that customer privacy preference is reflected correctly across the data landscape. In order to achieve that, she would need to understand the complete customer data traversal across enterprise. Which are the upstream, which are the downstream systems, what can modify the preference value. So let's look at the steps involved in solving this problem. We start with ingesting metadata from different sources, hosting customer information, and extracting customer knowledge from documentation. So bring the metadata and the information together. Leverage the entity resolution to build a customer 360 view and resolve any ambiguity in data as it comes from different sources. Bring in the regulatory data and connect it to identify and tag sensitive columns. Build, then go on to build a complete data lineage to showcase how the data traversed, including the application it touched, the environment it's hosted, the data pipelines, the data reports being derived, the logs that's storing the data, the downstream systems, etc. So once we have this kind of view, a 360 view of a customer, we know exactly where the data is, which system is storing what kind of data, and whether it's masked, it's encrypted, what is happening to the data, and if what can override the data as well, right? So when a customer updates the data retention flag to know, we can use the breadth and the depth search to identify the applications, stores, reports, logs, which need to be updated with the user preference and scrub any existing data and ensure that the action that we just perform does not get overwritten by something else which we didn't know about. Let's look at another example. As an asset manager, Peter is accountable for managing software across the infrastructure landscape. How will Peter be able to modernize and rationalize license across all the LOBs? With sustainability coming into picture, profitability coming into picture, a lot of emphasis is on usage of less and less resources, optimizing your server usage, optimizing your usage. So these kind of problem statements, which are very, very relevant to this era, need for solving these kind of problems, you need to have an understanding of the infrastructure landscape. So, how would Peter, who wants to reduce the number of duplicate licenses that we are using or replace an existing legacy software with a more modernized software with much more capability, can achieve this using a graph? Here also, we start with ingesting asset-related metadata from various LOBs and their application. For each data set, we build a 360 view, which includes the license type, the software capabilities, environment, usage patterns, and each of this asset can then be matched and merged into the relevant asset hierarchy. The resultant view can be used to find the non-utilized license, perform what-if analysis, etc., for a modernization journey, right? To summarize, Gardner says metadata is critical for holistic data management solutions. Connecting metadata in graph allows entities to be overlaid with business, operational, and social understanding of data, which, when leveraged, enables automation, insights, collaboration, and engagement. With that, I end the session and I thank you for your time for listening to me. If you have any questions, please do post it on the chat and I'll be happy to answer all of them.